Hi, smart students, welcome back to the Engineer Squad channel. In this video, we will work on a problem involving a bomb being released by an airplane. An airplane is flying horizontally at a speed of 90 meters per second and drops a bomb from a height of 500 meters above point A. How far from point A will the bomb land? Use a gravitational acceleration of 10 meters per second square. To solve this problem, we will start by drawing a free body diagram. The bomb is released above point A, with a horizontal velocity of 90 meters per second. Since the bomb takes time to fall, it will continue moving horizontally and will land at point B. The distance between points A and B is what the problem is asking for. This distance, we denote as Sx, represents the displacement along the x-axis. The formula for Sx is given by velocity along the x-axis multiplied by t, where the velocity along the x-axis, Vx, is 90 meters per second. However, we first need to analyze the value of t. To find t, we need to analyze the vertical motion of the bomb. The vertical distance traveled, or height h, can be determined using the formula v0y multiplied by t, plus or minus 1/2 times g, and multiplied by t square. Here, we substitute h with 500 meters. The initial vertical velocity, v0y, is 0 because the bomb is in free fall vertically. The bomb will accelerate downward due to gravity. Since the motion aligns with the direction of gravitational acceleration, we use the positive sign for gravity acceleration. Gravity is given as 10 meters per second square. The equation becomes 500 equals 5t square. Simplifying this, t square equals 100, or t equals plus or minus square root of 100. Taking the square root, we find t equals plus or minus 10 seconds. Since time cannot be negative, we select t equals 10 seconds. Before we continue this discussion, we kindly ask you to like this video and subscribe to the Engineer Squad channel. Thank you for your support. Your support means a lot to us. Now, let's continue with this problem discussion. We will substitute this 10 seconds into the equation for Sx, which gives us Sx equals 900 meters. This means the bomb will land 900 meters from the point where it was released. It shows that the bomb's accuracy is not very good, as it misses the target by 900 meters. To minimize this inaccuracy, aircraft in warfare typically fly as low as possible and dive sharply, giving the bomb an initial vertical velocity upon release, thus minimizing horizontal displacement. Additionally, to hit a target at point A, the bomb is usually dropped before reaching the point A, thus bomb can land precisely on the target. That concludes this discussion. Hopefully, it enhances our understanding of parabolic motion from a bomb, which combines uniform linear motion and uniformly accelerated motion. See you in the next physics problem discussion.